Section 1.8, Absolute Value Equations and Inequalities. In this section, we're going to have three different cases. The first case would be if we have an equation. So we have absolute value of x equals k. In this situation, we would have two equations. We would say x equals k or x equals negative k. On a number line, those are just two numbers. In a solution set, it's just a list of two numbers, so we use the curly brackets around negative k, comma k. We have something like case 2, where we have an absolute value is less than a constant, say k. Then our answer is going to be an and inequality. So negative k is less than x is less than k. Our solution set will be an interval, in this case negative k to k. And finally, if we have a case like case 3, where we have an absolute value of x is greater than a constant, then we're going to have our answer be an or situation, where x is either less than a number or it's greater than a certain number. This will give us two intervals that we're going to have to write as a union for our solution set. Our first example is like the first case, so since we have an equal sign, we're going to end up with just two numbers as our final answer. Recall back to Algebra 1, the way that we solve absolute value equations is we set up two equations. So we've got the inside of the absolute value, which is 5 minus 3x. We set that equal to 12. And then we also set 5 minus 3x equal to negative 12. Because whatever's in the absolute value could be a positive or a negative. So here we go. We're going to solve both of these. And then we get our final solution set as just the two numbers, negative 7/3 and 17/3. For this next problem, we're going to do the same thing. It's just like case 1, since we have an equal sign here. We're going to take 4x minus 3, and we're going to set it equal to a positive x plus 6, and we're going to set it equal to a negative x plus 6, which looks like this with the negative outside the parentheses, and solve each of these. Make sure to distribute your negative. So our final solution set for our answer is going to be the set of negative 3/5 and 3. This next example is case 2, since I have a less than sign here. So I'm going to set it up as negative k is less than x is less than positive k. So here's what that looks like. 7 is in the spot where k is, so I have negative 7 and a positive 7. And 2x plus 1 is in the spot where x is. So now I can solve this inequality. So we're going to have three columns here. We're working to get x alone in the middle. So subtract 1 in all three columns, and then divide by 2 in all three columns to get x alone. Just a reminder, if you ever divide by a negative, your signs are going to flip. On a number line, this would look like negative 4 here, 3 here, parentheses, and everything in between. So our interval for our answer in this problem is the interval negative 4 to 3, not including negative 4 and not including 3. The reason we're not including them and not using brackets is because I don't have an or equal to in my original problem. It's just a less than sign. This next example is an example of case number 3. So we have an absolute value is greater than a constant. So we're going to end up writing two inequalities. We're going to have 2x plus 1 is less than negative 7, or 2x plus 1 is greater than 7. Now we're just going to solve these two independent of each other. So subtract 1 over and divide by 2. Again, subtract 1 over and divide by 2. If we want to see our answer on a number line, we're going to put -4 and 3, and we're shading out this time because it's x is less than -4 or x is greater than 3. As an interval, we're going to have a union of two intervals here. We've got -infinity up to -4, not including -4, and then 3, not including 3, all the way to infinity. If my original problem had had an or equal to sign, I would have used brackets for the -4 and the 3. This next example, I need to start by moving the 1 over before I determine which case it is. So add the 1 over. And now we can see that it's case number 3, where I'm going to set up two inequalities with an or in the middle. I messed up something here, so I'm going to go back and erase. Okay, so here we go, solving. We're going to start by subtracting the 2 over, and then notice that we have to divide by -7. Anytime you divide by a negative, you've got to flip the sign. So I've changed my sign from a less than to a greater than on that first inequality. Same thing on the next one. We're going to subtract the 2 over and then divide by a -7, which is going to flip my sign. On a number line, we're going to plot -3/7 and 1. And we've got x is less than -3/7, so we're going to shade to the left with a parenthesis, and x is greater than 1, so we're going to shade to the right with a parenthesis. Again, we're using parentheses for -3/7 and 1 because my original problem does not have an or equal to sign under the inequality. Now we have a few special cases to watch for whenever we're solving absolute value inequalities. The first one is any time that we have an absolute value greater than a negative number. So our absolute value is always going to end up being something 0 or bigger. So this is actually always going to be true. So since it's always true for any number that we plug in, our solution is just going to be the interval of -infinity to +infinity. We don't even need to solve this problem. We just need to notice that we have something that's going to always have a true outcome. Okay, and for B, we have an absolute value less than a negative number. So we have something that's always going to be positive less than a negative number. That's never true. You can never have a positive number being less than a negative. So we're going to have no solution. The way we write that in set notation is just the empty set. So a circle with a line through it. The next special case that we're going to look at is anytime we have an absolute value equal to 0. Now this is like case number 1. Anytime we have an equal sign, we're going to write our equation twice. So normally we would put something like 5x plus 15 equals a positive 0, and 5x plus 15 equals a negative 0. But 0 isn't positive or negative, so we're not writing it twice. We're just going to write it once and solve it, and we will get one single number as our answer. So our answer is just the set that contains the number -3.